12.5, Solving Rational Equations. You can do this by multiplying both sides by the lowest common denominator to clear fractions. You can do it that way. You can also do it other ways. I will show you more than one way to do these. So in this first example, there is a 7 in the denominator, and on the other side you don't see a denominator, so the denominator is 1. And so if you think about what's the lowest or least common denominator between 7 and 1, it would be 7. What we would do here is we would just multiply both sides of the equation by 7 in order to clear the denominator. And those 7s turn into a 1, and you would distribute the 7 on the other side. And at that point, it's relatively straightforward to solve. Of course, you gotta work with the right numbers. So, gotta get rid of that 7. X on both sides. And then we would have to divide both sides by -6. Bring that on up here. And we would have 14 over 6 or -7 over 3. And let's try that again. Well, okay, over here, let's try their method and see if I can do it. We've got the denominators of 2, 3, and technically 1. The number that is maybe going to work for us here between 2, 3, and 1, let's see, 6. 2 goes into 6, 3 goes into 6. So let's try their method. Let's multiply everything by 6 and see if it clears the denominators. So we're going to multiply the entire equation by 6. I'm going to have 6 over 2 or 3. X plus 2 equals, and I'm going to multiply this next part of the equation by 6, and I would get 6 over 3 or 2x, and then multiply that last one by 6. Now I've got 30. Okay, that wasn't too bad. Now we don't have fractions anymore. Now we have 3x and 6 on one side, and we're going to isolate the x's by getting them all on the same side here in a minute. It's always a good idea to move the x's to the side where there's more x's. So I'm going to bring these 2 x's over here. And we'll subtract 6. And we're running out of room. X equals 24. Okay. That wasn't bad. So this strategy involves us finding the LCD of all the rational expressions in the problem and multiply every term by that LCD to solve the new equation. You must check your solutions. Oh, okay, all right. Even if you've made no mistakes, sometimes the solving process will introduce a false solution called an extraneous solution. False solutions make a denominator equal to 0 in the original equation. Okay, so we must remember to check our work. So if I were to check the work that I just did above, I would put 24 in for x everywhere. So that would look like this. 24 plus 2 over 2 equals 24 over 3 plus 5. All right, and so that would be 26 over 2 equals, what is 24 divided by 3? Sounds like 8. All right, and is 26 over 2, that's 13. Is 13 equal to 8 plus 5? I hope so. So that solution of 24 worked out. So that's what a check is going to look like. And let me do one more example for us all here. All right, these aren't going to be that bad, I don't think. Certainly not this first one. Okay, so let's start by writing it down. Give myself a little bit more space. 4 over x minus 3 equals x. And my denominator has an x minus 3 on one side, and there's no denominator on the other side, so I can just multiply both sides by x minus 3. Cancels out on this side, and now I have x squared minus 3x. Okay, now be careful. You can't isolate x with this one very easily because we have an x squared and an x term. And so we're going to have to set this one equal to 0 and see if we can factor it or do some other math here. All right, and so I've got some scratch work off to the side. Do I know anything that adds to make -4 but multiplies to make 3? I do. Well, 4 and 1, and it's -3, so that'll be -4. Okay, that's enough for me. So now I have x minus 4 and x plus 1 equal to 0. And I'll have two solutions. I will have the solution of x minus 4 being equal to 0 and x plus 1 equaling 0. So my answers, I've got 2 for x, at least I think I do at this point, 1 and 4. Okay, so I'm going to check my work, make sure none of those answers are extraneous, and let's check 1 first. 4 over 1 minus 3 equals 1. Okay. Well, I would hope if I did things right. I needed to add 1 to both sides down here. I needed to subtract 1 from both sides down here. So I'm going to check -1. Putting -1 in, I want to see if 4 over -1 minus 3 equals -1. And that would give us 4 over -4. Does that equal -1? Yep, -1 equals -1. All right, let's check the other one. That's going to be putting 4 in for x on both sides. 4 over 4 minus 3 equals 4. And we would have 4 over 1 equals 4. And that would be 4 equaling 4. 4 does equal 4. We're happy about that. Both of our solutions are real solutions. Okay, and so in this one, the LCD asked me what it was. I never answered it. It was x minus 3. The LCD for this one is, let's see, we've got 6 x's, and we've got 3 x's, and we've got a 2, and we got a 4. So I'm going to say that our LCD is going to be 4 minus 6 x's. Let's see how that works out for us. I'm going to multiply the entire equation, or in other words, both sides of the equation by 4 minus 6x. Normally, just for the record, the way I'd solve this would be to multiply both sides of my equation by the denominator separately and simplify, but we're trying something new. Let's see how we do. So we're going to have 4 minus 6x up here times 6x over 3x minus 2. And on the other side, we're doing the same thing. Okay. And the nice thing about me writing it in the same order as I was seeing is that I can just cross that off right now. So it's a 1, or it cancels itself. Now this side of my equation is quite nice. It's just a 4. Now what's going on over here? Let's see. I can see some things in common that maybe I could cross off. I'm looking at that 4 minus 6x, and I'm thinking about how I can get it to cancel out with anything going on in the denominator. So I'm going to rewrite it in the same way that the denominator is written. So I'm going to leave that alone. I'm going to leave the 6x alone. I'm going to write it as negative 6x plus 4. And I'm going to take a negative 2. Yeah, that sounds better. Negative 2 out of the numerator in that first parenthesis. So that'll be 3x minus 4. Okay. And that leaves us with 3x plus minus 2 in the denominator. And those cancel out, which I suppose this is why they like this strategy. And we are left with negative 12x equaling 4. And divide both sides by negative 12. And we now have x equals negative 1/3. Okay. Let's check it. 6 times negative 1/3 over 3 times negative 1/3 minus 2 equals 4 over 4 minus 6 times negative 1/3. And so we've got negative 2 over negative 1 minus 2, I hope, and then 4, I've got 4 plus 2. Okay, this will be 4 over 6, and this will be negative 2 over negative 3. That's looking okay. 2/3 equals 2/3. Okay, it does work. And that is not how I would have done that question at all. So let me see if the way I would have done it would have felt any better to any of you, because this is not my preferred method. So let me see if I'm going to clear all this work. And I'll show you the way that I would normally do this. All right, so again, I would ignore that. And I would just write the question down. And I would think about getting rid of the denominator because I don't like the denominator. I wouldn't really care about what the other denominator was. I could start with either one. And then I would cross that one off because that's why I did it. And then I'm going to leave the numerator alone for right now because I'm going to get rid of both denominators. Then I'm going to multiply this one on both sides. Four minus 6x. It's gone over here. And now I have I'm back to more of a comfortable place. I'll write the 6x first. And then I would distribute and solve on both sides. And I guess maybe the reason why you might not want to do this let's see. I would get negative, first I get 24x minus 36x squared. Well, we weren't getting an x squared before, so maybe the other method was better after all. And let's get everything onto one side. Let's bring it all over here. So I'm going to subtract the 24, and I'm going to add the 36x squared. So I'd get 36x squared minus 12x minus 8. And they've got a factor in common of 4. So 9x squared minus 3x minus 2. All right, I'm seeing the benefits of that other method now, I guess. Now, if I were to continue this one, I'd have to do my AC method. Let's keep going, see if I can do it. Otherwise, I'll just delete this part of the video. And so I've got to think about what multiplies to make 18 but adds to make 3. 6 and 3. So 6x and 3x. And I'm going to set up my box. I would have x, negative 6x, 3x, negative 8, negative 2, 9. And then we have 3x here, making this 3x and 1, and that'd make this a negative 2. Okay, so if we would have gone down the way that I normally would have gone down, we would have gotten our third, but we would have also gotten another answer of 2/3. So we would have, I'm curious if that was also an answer. Maybe we didn't find it in their method. Maybe my method is superior. So this one could have equaled 0. And this one could have equaled 0. And let's subtract 1 with 3x equals negative 1. Or x equals negative 1/3, the one they found. And then if I do the same thing over here, we'll add 2 to both sides. And divide by 3. We would get x equals 2/3. Okay, I'm curious about this one. Again, don't draw boxes around your answers. It's a bad habit. So let's see if 2/3 was also an answer, because in our other method, it wasn't found. So let's see. Was 2/3 an answer to this? 6 times 2/3 over 3 times 2/3 minus 2. Does that equal 4 over 4 minus 6 times 2/3? I don't know. The numerator of this one will be 12 over 3 or 4. And this will be 6 divided by 3, which is 2 minus 2. Oh, that's a problem. And this one will be 4 over 4 minus 12. Yeah, hopefully you're seeing the problem. This one's 4 over 0 equals 4 over 0. So the other solution we found was extraneous. So had we done the method that I typically do, we would have found an extraneous solution. So the other method was fine. It found that x equals negative 1/3, and it never found this one, and that one wasn't an answer, and that's why it's important to check. So you can do either one. You know, I think I might still stick with the one that I prefer of just getting rid of the denominators, but finding the LCD was kind of elegant. So go ahead and try that one, see if it works out well for you. Oh, that's crazy. All right, we'll stop there.